So in this question, we're told that the table below shows corresponding values of x and y for this equation here. So for y is equal to the square root of x over 1 plus x. So that's what we have there. And we're told that the values of y are given to 4 significant figures. So we can see we have a table here, and we've got all these values for x here, and then we have our y values, which are all to 4 significant figures. So what are we asked to do in this question? So we're asked to use the trapezium rule with all the values of y which are given in our table, and we are asked to find an estimate for the integral from 0.5 to 2.5 of the square root of x over 1 plus x. We're integrating with respect to x, and we're asked to give our answer to 3 significant figures. So we first recall what is the trapezium rule. So we know that this is going to be given by this formula here. So let us have the general case where we're integrating f of x with respect to x from x naught all the way to xn. Then we know we can use the following formula. So we know that it's going to be a half multiplied by h, which we'll come back to later. We'll explain what h is. And then we're going to multiply this by y naught plus yn. And then we're going to add on all of the other y values added up. So now, what we're going to do is we're going to have a look at our situation and see what our y naught is, our yn, y2, and so on and so forth, as well as h. So what I've done is I've copied the table down here, and what we can say is we know that this value here is going to be x naught, and we have x1, x2, x3, and finally x4. And similarly for our y's, we'll have y naught, y1, y2, y3, and y of 4. So in our case, we have that n is equal to 4. So now we're going to say what is h. So we know that h is going to be the difference between each x. So therefore, we'll just write that down. H is the difference between each x. So therefore, in our case, we have that we go from 0.5 to 1 to 1.5, 1.5 to 2, and 2 to 2.5. So we can see here that this is going to be 0.5, and then here, 0.5. So therefore, we can say our value of h is going to equal a half, so it's going to equal 0.5. So now we have all the information we need to substitute our values into this formula here to work out our integral. So therefore, taking the next step, we can say, therefore, our integral from 0.5 to 2.5, and what's the integral of? So we have x divided by 1 plus x. We square root that, and this is with respect to x. So we know this is going to be equal to, so we have 1/2, and we multiply by h. Well, what's h? We have 0.5, and then we're going to put in our big brackets, and then we're going to have y naught plus y of n. So in our case, we're going to have this value here, 0.5774, and then our y of n is y4 here, which is 0.8452. So we will have 0.5774, and we're going to add to that 0.8452. Then we're going to add on 2 lots of this value and this value and this value. So writing that down, we have 0.7071. Then we're going to add on 0.7746. And then finally, we're going to add on our y3 value, which is 0.8165. So therefore, we'll close our brackets, and we can just kind of digest what we've done there. So we've taken the values after we've identified them from the table, and we substitute them into our formula. So then what we can do is we can take our calculator and put all of these values in. So therefore, we make sure to be careful putting all the significant figures in, etc. And this comes out to be 1.50475, and then there's some further decimal places. So therefore, in the question, we were asked to round to 3 significant figures. So just writing a little concluding statement we have our integral, which goes from 0.5 to 2.5, and it's going to be of x divided by 1 plus x. We square root that, differentiate with respect to x. So the estimate, so we'll do the approximation symbol. We're asked to round to 3 significant figures, so this is going to be 1.50. And there we have our three significant figures, and we've completed the question. So this question was worth 3 marks, and we receive our first mark for identifying that our value of h was 0.5. We then receive our second mark for substituting our values into the formula correctly, and we receive the third and final mark for concluding with the correct answer. So now in part B of this question, we're asked to use our answer to part A, which I've copied down here, to deduce an estimate for this integral here. So this is the integral of 9x over 1 plus x, and we square root all of that, and we integrate with respect to x, with limits being from 0.5 to 2.5. So we have to have a look, what do we have in part A and what do we have in part B? And how can we move from this estimate to an estimate for this? So one thing we notice, the only difference here, is that we have the coefficient in front of the x, we have a 9, whereas we have 1 here, we have a 9 in this. But we know if we're integrating a constant, we can take it out of our integral. So what we can say, this is going to be equivalent to 2.5, 0.5, and then we can go the square root of 9 multiplied by x divided by 1 plus x, and we have our square root there still, and integrate with respect to x. And what we can do, since this root 9 is a constant, we can take it out. So I'll just write in here, this is a constant, so we can move it out the integral. So therefore, we have that this is going to be equal to, so we have the square root of 9 coming outside the integral, which is going to be equal to 3, and then our integral remains the same. So it's going to be 0.5, 2.5, and then we have x divided by 1 plus x, and then we take the square root of that and integrate with respect to x. But what do we notice now? This integral here, this is exactly the same as we had in part A. So what does this mean? So this means that we have now 3 in front of our integral. So therefore, we know that this is going to be the same estimate as our answer from part A, and to get our estimate for this, we're just going to multiply it by 3. So therefore, writing this out, we have that the integral from 0.5 to 2.5 of 9x over 1 plus x, and we're integrating with respect to x. So this is going to be approximately equal to 3 lots of our answer from part A, which was 1.50, and this is going to be equal to 4.50. So therefore, we've shown that the estimate of this integral here is 4.50. This question here was worth 1 mark, and we received 1 mark for having the correct answer. So in the next part of this question, we're told that the integral we're dealing with in part B, so the integral of the square root of 9x over 1 plus x, integrated with respect to x from 0.5 to 2.5, is equal to 4.535, and that's to 4 significant figures. And we are asked to comment on the accuracy of our answer in part B. So we recall our estimate from part B, so remember this was an estimate using the trapezium rule, and we had that this was 4.50. So what we can see here, we have a real value of 4.535 and an estimated value of 4.50. So from this, we can make the conclusion that we have an accurate estimate. Why is this? This is going to be because our estimate is very similar to our actual answer. So just writing it down, we can say that the accuracy of the answer in part B, we can say it's high. And why is this? This is because, so since we have that 4.50 is approximately equal to 4.535. So basically, the difference just comes from the fact that we've used different significant figures to round to. So therefore, we'll just annotate in here, this is the estimate, and we have that this is the real value. So therefore, we pick up 1 mark in this question, and that's for having this comparison when we say that the accuracy of our answer is good, it's high. And why is that? It's because our estimate is approximately equal to our real value. And therefore, we've completed this question.